Hey everyone, welcome to another problem session. So we're doing 2023 IIT JEE exams. These are really interesting problems, and this is in section 2. In section 2, every one of the possible answers, you have to check them out. You can't just say you want to get full credit, you have to work it out. If you found one of them and something you can't do it, just leave it that part, okay? To choose which is right, you have to actually work it out. All right, so this is annulus here, means inside is hollowed, and this is if the A becomes a B, then it just becomes a ring. A go to B limit doesn't mean you hollow out everything and this becomes a vacuum, the whole thing. All right. So here's a limit here. A goes to B. This doesn't mean A ever becomes equal to B. Okay. So A in part B, A goes to B does not mean A equals to B. There is always some material left, some distance left. Okay, which is so infinitesimally thin ring. So you get infinitesimally thin ring. So if you don't do this thinking and you just in your formula A go to B limit, like you take a math, you will be misled. Okay, so in physics when we say take a limit like this, then you have to go back and look at what did I get. Did I throw the baby with the bathwater, or what? Did I throw out the problem? So here it will remain ring. All right, so let's do this problem out. Those descriptions I hope you read. I'm going to redo the over here. So we have this annulus, but there is a static friction here, so that right now it's at rest. At some height above this, can be 0 also, there is an impulse applied, just kind of bang, you hit it. You might say I hit a bullet, it's got stuck. Negligible mass bullet, but considerable speed, it got stuck. Just brought some, let's put it over here so that you don't get confused with the inner part of the annulus. Okay, so you just hit. So this is at edge. So it will start to gain angular momentum, right? So if you look at it is a J0. This direction is X, this direction is Z. So what it would do, it's like a collision. You may have done problems like this, like you have a rod and a bullet hits here and just lodges itself, and the question is how it will rotate. You've done the problems like that, right? So it's kind of that kind of problem. So you have a J0 times H. So this is how much, like a torque times duration. So you might say it's angular impulse. So that will be the change in angular momentum. Initial angular momentum is 0, so it's going to pick up angular momentum. So this positive is going to pick up, we're going to say this kind of angular momentum. Let's call it omega. So it's going to become some I about point C, about the center. I'm going to call it O. I O omega. So, and because if H is if H equals to HM, this thing is going to roll without sleeping, and the radius is B, right? It's going to roll without sleeping, so rolls without sleeping if H equals to HM. So in that case, omega times B equals to the center of mass. That would be relationship, which it doesn't really tell you in terms of what to expect. Okay. So anyway, so this is equation 1, and this is equation 2 we can expect. The second expect is, think of all of this as a regular collision problem for center of mass. So J0 will be the total mass is m and v cm. So that's second equation. This is third equation. And of course you can write this is equal to m omega b when h equals to hm. This happens only when h equals hm. The third thing we need to know is what's I0. So this I0, well, as long as A doesn't equal to B, you know, as long as A doesn't go into the B, as long as the annulus will be is rotating about this axis here, then you can think of it as a negative mass, positive mass, and it's like a disk with the positive mass plus disk with the negative mass of that. That's going to be m over 2 b square minus a square. Not A goes to B. Okay. Now, when A goes to B, this I0 is, everything is on the ring now. So it's going to be mb square. So the I0 has different expression depending on whether you have this limit or just you have annulus. Okay, so let's see our choices here. It says when A goes to 0, hm is b over 2. So it has to do with h equal to hm. So h equal to hm, so we have a J0 equals m omega b. So I can combine these two, m omega b times h, using for J0 times this is J0, this time h, and I0 is m over 2 b square minus a square times omega. So this omega cancelled out, m cancelled out, and this is hm, and when a is 0, A equal to 0, that means the whole thing is a disk. So the HM is half B square over B is half B. So let's see if that's A is correct. Okay, so this means A correct. All right. The second one says A goes to B and still HM is equal to B. So we're going to do again HM, but this time I have same M omega B HM, but for I0 instead of this I have to use this because it goes to be 0. So this M0 MB square times omega. Of course omega cancels out from both sides, M cancels out, one of the B cancels out, so HM is going to be B in this case. So testing B, and I got the B correct. B is correct also. So for H equals HM, the initial angular velocity does not depend on the inner radius A. That's not quite true. That's not quite true. So so we have equation 1 and 2 and 3. So let's look at equation 1 itself. That's the initial is J0H over I0. I0 depends on M, B, and A. And it is saying that it doesn't depend on radius A, but it does depend on radius A when A is not equal to B. It's still annulus, right? So as long as when A equal to 0, you have a different answer than A not equal to 0. Then C is not correct. However, the last one, it says mu equal to 0, H equal to 0. The wheel always slides while rolling. So this one, you have to say if there is no friction to give you this force here so that it can roll, then it should slide. So this all it will always slide. So the D is also correct. So the D is correct, not from these equations, but just from using some physical reasoning here. Okay, so I would say A and B and D are correct for this. Okay, so I done with this problem, I think, question 6, and then the next question that I'm going to do is question 7, which turns out to be okay problem. I mean, it's kind of like a little vector problem, and we'll see how it goes. Okay, all right, see ya in the next problem. Bye.